Hello everyone, in this video we will talk about the chapter Rheology. Let's get started. If we talk about the definition of rheology, means it is the science or physics that concern with the flow of liquids and the डिफॉर्मेशन ऑफ सॉलिड्स. मीन्स रियोलॉजी एक ऐसी साइंस है जिसके अंदर आप लिक्विड्स के फ्लो की स्टडी करते हैं एंड डिफॉर्मेशन ऑफ सॉलिड्स के बारे में पढ़ते हैं. डिफॉर्मेशन मीन्स किसी भी मटेरियल की स्ट्रक्चर के अंदर इरेगुलरिटीज़ आ जाना ड्यू टू द अप्लाइड फोर्स. इफ़ वी डीपली सी द डेफिनेशन ऑफ रियोलॉजी, मीन्स इट इज़ अ ग्रीक वर्ड. रियो मीन्स फ्लो एंड लोजियो मीन्स स्टडी ऑफ. दस रियोलॉजी मीन्स स्टडी ऑफ फ्लो. बहुत सारे लिक्विड्स हैं जिनकी फ़्लो प्रॉपर्टीज़ बहुत ज़्यादा इंपॉर्टेंट है फार्मासिस्ट के लिए, जो काम करते हैं अलग अलग डोजेस फॉर्म बनाने में, जैसे कि सिंपल लिक्विड्स हैं, जेल्स हैं, ऑइंटमेंट्स हैं, क्रीम्स हैं एंड पेस्ट हैं. इन सिस्टम्स के अंदर चेंज आते हैं उनकी फ़्लो बिहेवियर के अंदर जब उन्हें एक्सपोज किया जाता है डिफरेंट स्ट्रेस कंडीशंस में. If you talk about fundamentals of rheology, first fundamental of rheology is that manufacturing of dosage form. अलग अलग मटेरियल्स हैं उनके अंदर क्या होती है, बहुत सारी प्रोसेस होती हैं जब उनको बनाया जाता है, लाइक मिक्सिंग, flowing through pipes, filling into the containers, etc. Flow related changes affect the selection of mixing equipment. Second fundamental of rheology is that handling of drugs for administration, like the syringeability of the medicines, the pouring of the liquids from containers, extrusion of ointment from tubes, all depend on the changes in flow behavior of dosage form. If we talk about different flow based on the rheology, that are of two types, Newtonian and non-Newtonian. First we will talk about Newtonian flow, after that we will talk about non-Newtonian flow. Let's start. Sir Isaac Newton was the first to study the flow properties of liquid in quantitative terms. Newton's law. According to this law, higher the viscosity of a liquid, the greater is the force per unit area, means shearing stress F required to produce a certain rate of shear. Means shearing stress is directly proportional to rate of shear. F present shearing stress, G present rate of shear. So F is directly proportional to G. If we eliminate proportional, then we can place eta in place of proportionality sign. Then we can write this. We can write F is equal to eta into G. Eta will present viscosity. Shearing stress F, it is also defined as force per unit area. We can write F is equal to small a upon a, means इसकी यूनिट डाइन पर सेंटीमीटर स्क्वेयर और न्यूटन पर मीटर स्क्वेयर. Higher viscosity of liquid, greater shear stress required to produce a certain G rate of shear, means dV by dt. Thus we can write F is directly proportional to dV by dt. F is equal to n dV, eta is dV by dt. Thus finally we can write F is equal to eta into G. Newtonian fluids means जो न्यूटन्स लॉ को ओबे करेंगे, like we can write F is equal to eta into G. In this case the curve for rate of shear and shearing stress will be linear, and the fluids which will show Newtonian fluids are water, oil, gasoline, alcohol, glycerin. If we talk about non-Newtonian flow, non-Newtonian fluids are the liquids which don't obey Newton's law are called non-Newtonian fluids. Example: slurries, suspension, gels, colloids, emulsions, ointments. We can also write the definition of shear. It is the movement of material relative to parallel layer. Three types of flow. Means there are three types of non-Newtonian flow, which are plastic flow, pseudoplastic flow, dilatant flow. First we start with the plastic flow. It is also called Bingham bodies, और इनके अंदर जो कर्व आएगा रेट ऑफ शेयर एंड शेयरिंग स्ट्रेस के बीच में वो ओरिजिन से पास नहीं करेगा. सेकेंड थिंग इज दैट द कर्व बिटवीन अ रेट ऑफ शेयर एंड शेयरिंग स्ट्रेस इज नॉन लीनियर. आफ्टर दैट द कर्व इज लीनियर. If you talk about the yield value, the linear portion extrapolated intersect the x-axis at the point called yield value. Plastic flow show Newtonian flow above the yield value. Equation describe plastic flow is U is equal to F minus small f upon G. Small f will represent yield value. Capital F will represent shearing stress, capital G will represent rate of shear. If we talk about the term plastic viscosity, it can be defined as the reciprocal of mobility is called plastic viscosity. Example, zinc oxide in mineral oil, paste, paints, ointments. Plastic flow explained by flocculated particles in concentrated suspensions, ointments, paste and gels. If we see the diagram for plastic flow, in this case flocculated particles will be present, which under the stress of field value will converted into individual particles, which further on applying stress will start to flow. Second flow is pseudoplastic. The curve for a pseudoplastic material begin at the origin. The curve rheogram for pseudoplastic material is due to shearing action on the long chain of materials such as linear polymers. No yield value is obtained. As shear stress increase, shear rate increase but not linear. Means in this case the curve between rate of shear and shearing stress will be non-linear. These are also called shear thinning system. Decrease in viscosity as the shear rate is increase. Means as we further increase shear rate, there will be decrease in viscosity. Give response on low shear rate resulting thixotropy. Thixotropic will be discussed further as a separate topic. Exponential equation describes pseudoplastic flow. We can write Fn is equal to eta into G, where capital N will represent number of given exponent, eta will represent viscosity coefficient. In case of a pseudoplastic flow, capital N is greater than 1, means the flow is Newtonian. Example, tragacanth in water, sodium alginate in water, methyl cellulose in water, sodium carboxymethyl cellulose in water. If we see the diagram of pseudoplastic flow, in this water molecules means polymer long chain with water molecules under the stress applied will convert so that it align in the direction of force, like this polymer and other water molecules align in direction of force. Third one is we will talk about dilatant flow. Certain suspension with a high percentage of dispersed solids exhibit an resistance to flow with increasing rate of shear. The rheogram for dilatant flow passing from origin. If we see the equation for dilatant flow, Fn is equal to eta into G. In this case, capital N will be less than 1, where capital N will represent number of given exponent, eta will represent viscosity coefficient. Such systems actually increase in volume when sheared are called dilatant. Dilatant materials means shear thickening systems. When the stress is removed, a dilatant system returns to its original state of fluidity. In dilatant system, viscosity increase with the rate of shear strain. Example, starch in water, sand in water, potassium silicate in water. If we see the diagram for dilatant system, in this case we can see that at rest, close packed, less void volume, sufficient vehicle, low consistency. Increasing rate of shear, we can see that open packed, high void volume, insufficient vehicle with high consistency. Here we can see the different diagrams of different flow, like for Newtonian fluid we can see the graph is linear. In case of plastic flow, the graph is firstly non-linear, after that is linear. In pseudoplastic flow, the graph is completely non-linear, and dilatant, in case of dilatant flow, the curve is non-linear. Thank you for watching my video. Please share, subscribe and like my video.